Namaste everyone. Welcome to physics class, second physics class. We are studying about, we are in atoms now. We have studied Rutherford's model, how did Rutherford's alpha particle scattering experiment ruled out Thomson's model, and how did Rutherford gave planetary model, and later on the classical theory used by Rutherford failed to explain how the stability of the atom is, and later on Bohr made a small change saying that the energy of the electron, or sorry, the orbit prescription or selection of orbits is not arbitrary. It should be done with some precautions and some rules, and he said that angular momentum of the electron in a prescribed orbit should be an nh by 2 pi, should be a product of n times the h by 2 pi. And so Bohr gave some ideas, and he said that as long as electron is in that non-radiating orbits, it will not emit emit any radiations, and it will not emit energy. It will continue to be in the same non-radiating orbit. Suppose it loses energy, it will no longer continue in that orbit. It will jump to another orbit, okay? Which is also non-radiating, again another orbit, but it is another stable orbit. It will never come to nucleus. Its orbit will not go on shrinking like a spiral path. Okay, using these Bohr's postulates, let us try to get the velocity of the particle, velocity of the electron in a particular orbit, and radius of the electron in a particular orbit, and energy of the electron. So we have so many derivations here. All the derivations are very easy to learn because they depend on only two equations. One is the centripetal force given to the electron is the electrostatic force of attraction between the positively charged nucleus and negatively charged electron, and next one is angular momentum is equal to nh by 2 pi. So according to Bohr's postulate, so shall we start from, so can you see here if I write here? Yes, we will start from radius first, radius of electron. So consider an electron of mass m and the charge E minus E actually moving in a circular path with a speed v at a distance r, that means radius of the circular path is r, around a nucleus of charge plus Ze. Why Z? Z is the number of protons inside the nucleus which give positive charge to the nucleus, and if Z number of protons are found, each proton is having a charge E which is same as the charge of electron, but polarity is opposite. The charge of electron is minus 1.602 into 10 to the power minus 19. Charge of proton is plus 1.602 into 10 to the power minus 19. So plus Ze is the charge of nucleus. If there are Z protons, Z into E. And this is the charge of electron is minus E. Now, if you want to find out radius, first use the condition for the rotation in the circular path, that is centripetal force is given by the electrostatic force of attraction. You know, electrostatic force between any two charges is 1 by 4 pi epsilon naught. Epsilon naught is the permittivity. You have watched that video, I think. Q1 Q2 by r squared, magnitude of first charge, magnitude of second charge, their product by distance squared. What is the magnitude of the first charge? It is electron charge, okay, Ze anything, and E divided by distance is the radius itself. So shall I cancel one r and retain another one? So mv square is equal to Ze square divided by 4 pi epsilon naught r. Hope you have pen and paper. You are going along with me, right? You have to take a pen and paper. If you don't have pen and paper, pause the video, go and get a pen and paper, then start writing. Don't waste the time just by listening and observing me in the video, right? So keep on working out along with me. Right, this is one equation. We got mv squared. Later on, this equation is very useful to find out the kinetic energy of the electron. Just multiply here by half mv square, half. It becomes half mv square. Okay, right, now it is not needed. Just I have given a clue. What is the condition for the selection of orbits? Angular momentum, moment of momentum, mvr, must be equal to nh by 2 pi, where n can take the values 1, 2, 3, 4 integer values only. That means if the electron the angular momentum is h by 2 pi, it is the first orbit. 2h by 2 pi, it is the second orbit. If it is 1.5 to h by 2 pi, no orbit is possible there. If the angular momentum of an electron is 3.33 h by 2 pi, no orbit is possible. It should be an integral multiple of h by 2 pi. Second equation. Okay, now change this one. Yes, what I can do, change this to V and substitute V here, m square, then you will get the answer. Or, okay, that is better, change it to V. What is V is equal to? Velocity of the electron is equal to nh by 2 pi mr. nh by 2 pi mr. Now, substitute this equation in 1. So, what 1 becomes? So, I don't write sentences and all. 1 becomes mv square, m into, what is v square? V square is n square h square divided by 4 pi square m square r square. Right? N square h square divided by 4 pi square m square r square. That is v square. This is equation 1. I am writing equation 1. Equation 1 becomes, mv square, z square divided by 4 pi epsilon naught r. Yes. Okay. So substituting v here, we got this one. Now I want radius, right? I want the radius equation. So what I can cancel? I will cancel 1 r here. 1 r cancels here. So r remains here. I bring this r here, remaining things here. R is equal to only r here, remaining all here. This one here, right? M, n square, h square. This one, 4 pi epsilon naught. Okay, and what else? Divided by 4 pi epsilon naught n square h square divided by 4 pi square m square, r is taken here, z square. Okay, 4 getting cancelled, 1 pi remains here, 1 pi gets cancelled, 1 m gets cancelled, then what else remaining? Epsilon naught n square h square divided by pi m z square. This is the answer for radius. So radius of the electron orbit in hydrogen atom is given by epsilon naught n square h square divided by pi m z square. What you have to do is you will get such formulas, some 4 to 5 formulas in this chapter. Write them in a big sheet in large dark colors, put it on the walls in your room. Every now and then observe those formulas, then you will get it, and use those formulas every now and then only you can remember it. Otherwise you can't remember these formulas. Epsilon naught n square h square by pi m z square. But when in the examination, suppose it is asked for 5 marks, state Bohr's postulates. Right? One is angular momentum equal to nh by 2 pi, centripetal force is given by the electrostatic force, electrons are always moving in non-radiating orbits. As long as they are in the non-radiating orbits, they don't lose energy. If they lose energy, they will go to another non-radiating orbits. Energy liberated is equal to h nu, E2 minus E1 equal to h nu. All these statements. Then obtain an expression for radius. Consider an electron moving in a circular path of radius r around a nucleus of atomic number z. M be the mass of the electron, E the charge of the electron, centripetal force is given by this, and angular momentum, club them, get V, substitute here, you will get this answer. But in the examination, you have to apply this radius for hydrogen atom. Bohr, while using his theory, or applying his theory, he applied it for the tiny atom, that is hydrogen atom, hydrogen nucleus, which contains 1 proton. And when it is applied for hydrogen nucleus, you have to take z equal to 1, right? So you are not going to write about this, you are not going to write about this, it is plus E, plus 1E, and you are not going to write in this, you are not going to write z here. No z, no z, no z. So all z's will have to be removed while doing it in the exam. Sir, why did you keep that z then? Because if you are writing entrance examination, z is very much needed. How does radius change with z? If it is hydrogen, z is equal to 1, okay. If it is helium, if it is beryllium, if it is thorium, sorry, not up to that, up to thorium you can't go. So if it is some other element, where hydrogen like atoms, what is the radius? Then you must know z here. Where does z come? In the theory exam, you write without z. But please try to know where z comes. So I study this with z. In the examination, leaving Z is not such a big thing. So for hydrogen, Z equal to 1. So take it like this and then continue. And epsilon naught n square s square pi m Z 1 e square. This is the radius of the electron in any orbit. Okay, now we will analyze this equation. We have derived this in the last class also. So be ready with pen and paper always, and write the derivation whatever I say, because every derivation is important from this chapter. Either problem or definition, derivation is 100% expected. Okay, now my question is, one electron absorbs energy from one non-radiating orbit, it goes to the next radiating orbit, right? Non-radiating orbit. So it goes to the higher energy level, revolves around in another prescribed path where its orbital angular momentum will be another h by 2 pi, either 5h by 2 pi to 6h by 2 pi, something like that. Radius of the outer orbits. When the electron jumps from one inner orbit to the outer orbit, in this formula, what is that changing? That is important now. What is the factor which is changing when the electron jumps from one orbit to another orbit? Epsilon naught doesn't change because it is vacuum everywhere, wherever the orbit is. N will change from 5 to 6, 1 to 2, 3 to 4. H will not change, pi will not change, m will not change, E will not change. That means in this equation, except N, when the electron jumps from one orbit to another, except N, nothing will change. So shall I write, radius of the orbit of any electron is directly proportional to n square? What do you mean by this, sir? Suppose the radius of the first orbit is r. What is the radius of the next orbit? First orbit is 1, n equal to 1. So if you put the condition n equal to 1, if the angular momentum of the electron is mvr, if it is equal to 1h by 2 pi, then that should be first orbit, right? If the angular momentum of an electron in any orbit is 5h by 2 pi, it is the fifth orbit. Now it is first orbit means 1 square. What about second orbit? When you put 1 square here, suppose we will apply this. Radius of the first orbit of hydrogen atom, that is the smallest orbit and the simplest orbit. And Bohr applied this equation for the first orbit of hydrogen atom, and it is called Bohr orbit or Bohr's orbit. Radius of the first orbit of hydrogen atom is called Bohr's orbit, and A naught I will take. R is taken as A naught. What I have to do now? Substitute the values. Epsilon naught 8.854 into 10 to the power minus 12. N square, 1 square. First orbit of hydrogen atom is called Bohr's orbit. Electron in the simplest hydrogen atom in the first orbit. It is the smallest application, basic application of the theory. What answer we will get? 0.854 into 10 to the power minus 12. N square, 1 square. H is 6.6 into 10 to the power minus 34 divided by, in the examination you need not find it out, remember the answer, that is very much needed, 3.14, and mass of the electron is 9.1 into 10 to the power minus 31 kg, and E square is 1.6 into 10 to the power minus 19, 1.602 into 10 to the power minus 19 coulombs, and square. Got it now? What is the answer of this? It is 0.53 angstroms. You can check it. If you have calculator, you can check it. It will be almost equal to 0.53 into 10 to the power minus 10 meters. Yes, 8.854 into 6.6 divided by 3.14 divided by 9.1 divided by 1.6 divided by 1.6. So you will get, don't get anywhere we have gone wrong. Epsilon naught n square h square. Oh, h square. That means you have to multiply it by 6.6 again. Yes, you get this. 6.6 into 10 to the power minus 3. Check it yourself. You get this? This is the answer. So Bohr gave an equation for radius, because this assumption, of course, centripetal force is equal to electrostatic force was also given by Rutherford, but this is not given by Rutherford. It was given by Bohr. So Niels Bohr gave that some idea to construct an atom. Using that base, we were able to get a radius. Of course, Bohr got an equation for a radius, for the radius of an electron, radius of the path of the electron, and it is like this. And if you apply it for the simplest atom, that is hydrogen, you get the answer like this, A0 is equal to this much. Now if you go to the second orbit of hydrogen atom, what will you do? If you want to go to the second orbit, just change 1 square as 2 square, correct? It is 4 times this one. That's all. That is what I have written here. If you want to know the radius of the third orbit of hydrogen atom, just put 3 square. That's all. Everything else remains the same. Multiply this by n. So shall I write radius of the first orbit of any atom, right? R1 is to R2 is to R3 must be equal to 1 square is to 2 square is to 3 square is to 16 is to, correct? So radius of any orbit of any electron is in the order n square. So what do you mean by this? The second orbit is 4 times larger than the first orbit. The third orbit is 9 times larger than the first orbit. The fourth orbit is 16 times larger than the first orbit, and the fifth orbit is 25 times larger than the first orbit. So that is the meaning. So if first orbit is capital R radius, second orbit will be 4r, next orbit will be 9r, next orbit will be 16r, 25r, 36r, like this. So radius of the orbits are in the order of n square, quantum numbers, square of the quantum numbers. So if you want to know what is the seventh orbit of radius of the seventh orbit of the hydrogen atom, it is 0.53 into 10 to the power minus 10 into 49, because you will have to change only here 7 square, that's all. So now you see this answer. The value of the radius of the first orbit of hydrogen atom obtained is 0.53 into 10 to the power minus 10 meter, so many angstroms, 0.53 angstroms. This value itself is a proof to say that Bohr's model of hydrogen atom is almost correct. Why? You see here 10 to the power minus 10. What does Rutherford alpha particle scattering experiment say? It says that nucleus is very small and size of the nucleus is of order of 10 to the power minus 15 meters, 1 Fermi, or 10 to the power minus 14 meters, and atom is some 10,000 times greater than the size of the nucleus. When you multiply 10 to the power minus 14 or 10 to the power minus 15 almost by 10,000, you will get 10 to the power minus 10 of order, right? That means this is answer is also showing that it is 10 to the power minus 10. Moreover, kinetic theory of gases say that size of the atom should be almost 1 angstrom or 10 to the power minus 10. This also shows that, because size of the orbit itself is the size of the atom, isn't it? Because at the outermost part we have electrons, nucleus is at the center. The size of the orbit of the electron, circular orbit of the electron, should be the size of the atom. It clearly says that size of the atom should be of the order of angstroms, 10 to the power minus 10. So all the things agree with each other. So that is the radius. So radius of the first orbit of hydrogen atom is called Bohr radius, and its radius is called Bohr radius, not Bohr orbit, it is Bohr radius, and the value of Bohr radius is 0.53 angstroms. Got it now? So one derivation is over. What is velocity, sir? So this you have to remember. For entrance exam, this is very much needed. Radius is directly proportional to n square, and another one, radius is inversely proportional to z, correct? That is why I have written z. Radius is directly proportional to n square, inversely proportional to z. What do you mean by inversely proportional to z? More the atomic number, smaller will be the radius. That means if you compare the same radius. What about the first orbit of hydrogen atom and first orbit of helium atom? First orbit of hydrogen atom and first orbit of helium atom. Helium means 2 protons, right? 2 He4, hydrogen 1 proton. What is the difference? First orbit of hydrogen atom is larger because Z is 1. Z is less. First orbit of helium atom is first orbit of an electron in the helium atom is lesser, smaller. Why? Because Z is more. And another conclusion, why it may be so? Because when there are more and more protons inside the nucleus, when Z is more and more, what about the attraction force on the electron? When there are more number of people, protons here, attracting electron, what should happen to the size of the radius of the circular orbit? It should go on shrinking, right? That means more the z value, smaller will be the radius. I am comparing the same orbit, right? For example, 5th orbit of hydrogen, 5th orbit of helium, 5th orbit of lithium. So if you go on increasing z, 5th orbit of hydrogen will be larger because in the nucleus there is only one proton. It cannot attract as much as the helium nucleus attracts the electron. So because helium nucleus contains more protons. So first orbit of hydrogen will be larger. First orbit, the same orbit, first orbit of helium will be little smaller. Lithium will be still smaller. That's how you have to remember the dependence. Don't simply remember radius is inversely proportional to z, radius is inversely proportional to z. No use. Radius is inversely proportional to z, directly proportional to n square. That is the meaning. Okay? If you go outer or radius, size is more. In the same atom I am talking about. N square. First orbit of hydrogen, second orbit of hydrogen, third orbit of hydrogen only. Then it is 1 square, 2 square, 3 square. And if you are changing the atom, R is inversely proportional to z. That means the second orbit of hydrogen only, second orbit of helium only, second orbit of same orbit but in different atoms. As z increases, radius decreases. Okay, velocity. What is the velocity of the electron? Okay, we will have to get this now. So how do you get the velocity, sir? Already we have got an equation for velocity, nh by 2 pi mr. That is not enough for us because there is r. Substitute for that. Velocity is equal to nh divided by 2 pi m r. What is r? Epsilon naught n square h square divided by pi m z square. Epsilon naught n square h square divided by pi m z square, that is radius. So try to remember the formula. Cancel the unwanted pi. What is the remaining? N, 1n gets cancelled, right? 1n gets cancelled. Z square, h will get cancelled, right? Here is h square. So 1h will get cancelled. Velocity of the electron in any orbit is z square divided by 2 epsilon naught nh. Now you see, velocity of the electron in any orbit is directly proportional to z, inversely proportional to n. That is what is needed. And if you are asked to derive the equation for velocity of the electron in the hydrogen atom, because we have application only for hydrogen atom, velocity of the electron in the hydrogen atom, delete z. Z is 1, z is 1, and only we have velocity is equal to E square divided by 2 epsilon naught nh. In the PDF I have given notes, you don't have z, we have omitted z. So, but study with z. Deleting z in the examination is not a difficult task, but after studying without z everything, remembering z, where to remember z, whether it is in the numerator, whether it is in the denominator, whether it is z square, inverse proportional z square, don't know. So instead of that, this is better. So that is velocity. So velocity is inversely proportional to n. What do you mean by velocity is inversely proportional to n? As the electron goes to the outer and outer orbits, its velocity in the same atom, z constant, everything constant except n. When the electron moves to the outer orbits in the hydrogen atom, its speed will be lesser and lesser and lesser. Everything is a constant, right? Except that everything will be constant. So that is one thing. So radius is important here. Velocity, of course, a byproduct. Now we will go for energy of the electron. That is very important. So shall we move on to the next derivation now only? Radius over, velocity over. Now energy of the electron. Yes. Now when the electron revolves around the nucleus, if you take a stone and turn it, rotate it in a circular path, that electron or that rotating stone will be definitely moving, so it will have kinetic energy. So this electron moving in the circular path, it is having some velocity, so it will have kinetic energy. So there is kinetic energy, and it will also have potential energy. Alright, P, enough. An electron revolving around the nucleus has got both kinetic as well as potential energies. Why potential? Because it has been bound to the nucleus. We are on the surface of the earth. We are bound to the earth. we are not free. And if you want to become free from the potential energy of the earth, negative potential energy it is, because you are bound to the earth, and if you want to become free, you should use all your energy and you should run and run and run with such a speed that your speed should cross escape speed of the earth and you will fly away. But it is not possible, very difficult to have such energies. Or you have to take the help of rockets and other cryogenic engines and you have to take a lift. But that is also very costly. So better to be bound to the earth, right? As you are thrown away and away and away, you become free from the earth. It is as if you take a loan from the bank, right? I have 1 crore rupees, but it's a loan, it is negative. Right? It is not as if you have 1 crore wealth. Wealth is different, loan is different. If you have 1 crore rupees a loan, a beggar is better than a person having 1 crore loan. Why? Because beggar is having zero asset. His wealth is zero. He is just requesting others for his today's meal. But he is not having loan. His money is, today's money is zero. And the person who is having the loan in the bank is minus 1 crore. And minus 1 crore is in the worst position. Zero is the best position. Zero is greater than minus. Similarly, electron revolving around the nucleus in the circular orbits have negative energy, because its potential energy is more. Now for example, when you are running on the ground, don't you have kinetic energy? Yes, that is positive. Kinetic energy can never be negative. It is always positive. And when you run on the ground, your kinetic energy is positive. Now what about the bound energy, sir? Whether we are bound to the earth, still we are bound to the earth. Why? Because the potential energy with which we are bound to the earth is much, much greater. It is as if you have 100 rupees in your pocket, but minus 1 crore loan. Even if you have 100 rupees in your pocket and if you have 1 crore loan, still you are under the control of the bank. Because even if you pay that 100 rupees, how much is remaining? 99 lakhs, 9,999 or 9,900 rupees is remaining. 99 lakhs, 9,900 rupees remaining. So it is not at all enough. So it's in the same way, electron revolving around the nucleus has got kinetic energy, is bound to the nucleus, so has got potential energy, bound potential energy minus, and its total energy is negative, because the energy with which it is bound to the nucleus, that is negative potential energy, is much more, and the energy with which it is revolving around is less. Suppose you want to make the electron a beggar, means zero energy. You have to release it from the control of the nucleus. What you have to do? Supply energy to the electron, either in the form of light or in the form of heat. We are doing it, right? And or in the form of electric and magnetic field or secondary electrons, right? Then electron absorbs the energy from the outside in the form of photons or heat energy, whatever it is, and it can become free. What do you mean by it is becoming free? If you give sufficient energy, electrons energy, negative energy, potential energy can be made zero. It just comes out of the material. So this electron is bound to the nucleus. So totally electron has got two energies. One is potential, another is kinetic. Potential is negative, kinetic is positive, but negative is more, positive is less. So total is negative. It is like this. You have minus 100 plus 50, and that is equal to minus 50, like this. Kinetic energy is positive but less. Potential energy is negative, minus. So total energy is minus. It is same as kinetic, but it is minus. So how to get the expression for total energy of the electron revolving around the nucleus? Now we will do it like this. So very simple. First go for that centripetal force. Bohr's theory again. What does centripetal force say? The centripetal force for the electron revolving around the nucleus is given by the electrostatic force of attraction, 1 by 4 pi epsilon naught, Q1, Q2, because magnitude of the charges, divided by distance square, right? So without looking into that first chapter video, you will never be able to follow this. You must see that up to Coulomb's law. The force of attraction between the two charges separated by a distance is inversely proportional to the square of the distance, directly proportional to the product of the charges, magnitude of charges. Okay, now 1 r I will cancel. I will get mv square. Mv square is equal to Ze square divided by 4 pi epsilon naught r. Now what is kinetic energy? EK I will write, half mE square. We know kinetic energy is equal to half mE square. From where do you get half mE square? Multiply this to half. So what you will get? So you have to write half here. Then what you will get? ZE square divided by 8 pi epsilon naught r. This is equation 1. That is kinetic energy. ZE square by 8 pi epsilon naught r gives the kinetic energy. Now what is potential energy? It is bound energy. A positively charged nucleus, a negatively charged electron, always attracting each other. A earth of certain mass, a satellite of another mass, always revolving around the earth. It is always under the gravitational pull of the earth. That means that satellite is under the influence of the earth. Okay. Now, what is the potential energy between two charges, Q1, Q2, separated by a distance r? Potential energy between a system of charges, same formula, Q1, Q2, but not r square, r, that's all. Potential energy between a system of two charges Q1 and Q2 separated by a certain distance is 1 by 4 pi epsilon naught Q1, Q2 divided by distance, that's all. But in potential energy, we have negative and positive signs. They have their own importance. Negative potential energy means they are bound to each other. Positive potential energy is they are not bound, they are free. Okay. Now let us try to write the potential energy between the positively charged nucleus, negatively charged electron. What is the potential energy? EP I will write 1 by 4 pi epsilon naught Q1 plus ZE, Q2 minus E. Because it is bound, I want to show that it is bound. I can't say I have 1 crore rupees because it is a loan from the bank. I have to mention it, right? I can't say that it is my own money, it is the bank's money. I have to repay it. So ZE into minus E, it is bound to the nucleus. And here, of course, here we don't write E, minus E. The reason is very simple. Since it is force of attraction itself, that was acting like a centripetal force. Otherwise, how could it be the centripetal force? If an object has to move in the circular path, you need a pulling force towards the center, isn't it? Since Earth is pulling the satellite, that acts like a centripetal force. Suppose Earth was repelling the satellite, it would not have acted like a centripetal force. Now, that's why they are equal. That's what we say. We need not have a negative sign there. Here we have a negative sign because it is bound to the Earth. So distance r. Potential energy is the same formula, electrostatic force formula, but without r square, only r. So what is the potential energy? EP is equal to ZE square minus divided by 4 pi epsilon naught r. Equation 2. We have potential energy, we have kinetic energy. You see, just see this number minus 100 loan, plus 50 pocket. But still you are under the loan, right? I have 50 rupees in my pocket, but I have made 100 rupees loan with the bank. But still I am under loan only, because if I give 50 rupees to the bank, still minus 50 is remaining. So similarly here you see, kinetic energy positive by 8, same formula but negative, ZE square by 8 pi epsilon naught r, 4 pi epsilon naught r, which is greater? This one is greater, divided by 4 only, numerator less. Numerator denominator less, denominator more. So shall I write that potential energy is greater than magnitude wise kinetic energy? That's why total energy is negative. Minus 100 plus 50, minus 50 answer. So, or shall I write potential energy is equal to minus 2 times kinetic energy? Is it so? Multiply this by 2, give a negative sign. This one. Am I right? Multiply this by 2 and give a negative sign. Then you will get this one. When you multiply this by 2, that means kinetic energy into 2. Then it becomes 4. This answer. And you should give a negative sign. That's all. So, potential energy is minus 2 times the kinetic energy. What is the total energy? Shall we write it here? Total energy of the electron, E kinetic plus E potential. Total energy of the electron. We'll do this. You have to complete this now. Yes. I want to have some colored chart. Potential energy. Total energy is kinetic. Where is kinetic? Kinetic ZE square divided by 8 pi epsilon naught r minus potential minus ZD square divided by 4 pi epsilon. Feeling tired? Yeah. What is this? Everything is same except 8 and 4. So what is the total energy? I'll put a bar here. I think you can see this. Yes. E is equal to ZD square divided by pi epsilon naught R into 1 by 8 minus 1 by 4. So what is total energy? E is equal to, yes, chalk absorbs vapor or moisture and it is not strong now. Z square pi epsilon naught R into 8 common, 1s are, 2s are, 1 minus 2. Minus 1 by 8. So total energy is negative. So do you remember that minus 100 plus 50 is equal to minus 50, potential, kinetic and total, right? So answer here is same as kinetic but negative. Total energy is same as kinetic but negative, but potential energy double is kinetic. Okay, E is equal to, what you will get then? The answer is minus ZD square, because 1 minus 2 is minus 1, by 8 pi epsilon naught R, which is same as 8 pi epsilon naught R, which is same as, where is it? But minus. It is same as kinetic but minus. But final answer is not over. I want to substitute R, total energy of the electron. Shall I rub this? Total energy of the electron minus ZD square divided by 8 pi epsilon naught R. R is, I don't have, but I remember, epsilon naught n square h square. It is in the denominator, R. Epsilon naught n square h square pi m z square. Correct? Epsilon naught n square h square pi m z square. Yes. Pi gets cancelled. What else? Yes, nothing I think. Yeah. Energy total is equal to minus z square e to the power 4 m divided by 8 epsilon naught square n square h square. So total energy of the electron rotating in a circular orbit of radius r around a nucleus of atomic number z is minus z square e to the power 4m divided by 8 epsilon naught n square h square. So what does this say now? Total energy of the electron is directly proportional to z square. Of course it is negative, inversely proportional to n square. That's what I can say, right? Now Bohr got this answer and the energy for the total. Of course, again the derivation, I have to compete with that train now. So again Bohr applied this only for the hydrogen atom. So Z you have to delete. Z equal to 1, Z equal to 1. So you have the formula minus e to the power 4m divided by 8 epsilon naught square n square h square. And he applied it to the simplest atom again, energy of the electron in the ground state of hydrogen atom, because already the energy of the electron or the energy required to remove the electron from hydrogen atom was already calculated. The energy required to remove the electron from the hydrogen atom must be the bound energy of the electron, isn't it? Suppose you go and talk to your friend, how much I have to pay you, so that you are very generous, you want to help your friend. How you are asking your friend, how much I have to pay you so that you become free from the bank? Then your friend says 1 crore. Why? Because minus 1 crore loan in the bank, right? You have to give plus 1 crore. Similarly, if you try to remove an electron from the hydrogen atom, how much energy you have spent in removing the electron from the hydrogen atom? That must be the bound energy of the electron. It was already calculated even before Bohr gave this theory. What is the minimum energy required to remove the electron from the hydrogen atom? It was already known. Now, if the energy of the electron in the innermost orbit of hydrogen atom is calculated, then it is negative, and if you give so much positive, electron comes out, right? What is the value of the electron energy in the innermost orbit of hydrogen atom? If you substitute z equal to 1 and n equal to 1, first orbit, how much you get? Then it was calculated. Energy of the electron in the innermost orbit of the hydrogen atom is calculated minus 1.602 into 10 to the power minus 19, it is enough. 1.6 is enough. 1.6 into 10 to the power minus 19 to the power 4, 9.1 into 10 to the power minus 31 kg, 8 into 8.854 into 10 to the power minus 12 whole square, n square 1 square, h squared 6.6 into 10 to the power minus 34. You see, again and again using these values makes it very strong. You can't, you need not by heart it. If you select this and what the value you get, divide it by 1.6 into 10 to the power minus 19 and convert it into electron volt. What the answer you get here, do it yourself after completing the class. Divide it by 1.6 into 10 to the power minus 19. You will get an answer which is as minus, of course I have forgotten to write minus, then this is minus 13.6 eV. This energy was calculated or compared with the energy required to remove an electron, knock out an electron from the hydrogen atom. Ionization energy, we call it. Energy required to knock out an electron from the hydrogen atom, that is called ionization energy of hydrogen atom. This value and that value was found to be very close to each other. Again another support to the Bohr's theory, saying that Bohr's theory is almost correct. So the ionization energy calculated using Bohr's theory, that is all the theoretical values, and the practically observed ionization energy answer were found to be true, and they are very close to each other within the limits of experimental errors. There may be a very small difference, and so that is a boost to the Bohr's theory. So this is the energy of the electron in the innermost orbit of hydrogen atom. Formula is important, answer is important, and of course all the dependence. Energy, of course this is one, but suppose you go for helium, lithium, beryllium like this, energy is directly proportional to z square, inversely proportional to n square. Energy is inversely proportional to n square. So if I write this as E1, energy of the electron in the innermost first orbit of hydrogen atom, E1. What is E2? Can you tell me? E2 is E1 by 2 square. Why? Because in all substitution only this changes. Instead of 1 you have to write 2 square, 4. That is E1 by 4, and this comes to minus 3.4 electron volt. What is the energy of the electron in the third orbit of hydrogen atom? By 3 square, that is by 9, that's all. Minus 1.51, something like that you will get. Again, energy in the 7th orbit by 49, energy in the 5th orbit by 25. So energy in any orbit is inversely proportional to n square, because total energy is inversely proportional to n square. That is very important, right? So energy of the electron in the hydrogen orbit, first orbit of hydrogen, is minus 13.6 eV. That is the ground state energy, and this energy is calculated using Bohr's theory, and the formula for total energy is z square minus z square e to the power 4 m 8 pi epsilon naught n square h square. Negative sign indicates that electron is bound to the nucleus and it is under the control of the nucleus. And another thing is, sir, if an electron is found in the innermost orbit of hydrogen atom, say first orbit, we give energy to it in the form of light. Of course it is not enough to remove it, but still it is enough to go to the second energy level, because the energy levels are fixed, right? You can't give any energy and make the electron to come anywhere. Either you should be, your friend should be inside the pit, or he should be outside the pit. If you want to help him, completely remove him from the pit, right? Instead, I will remove half today, remaining half I will remove tomorrow. If you say like that, your friend will be in a dangerous position, right? If you remove him half and leave him, he will fall down. So in the same way, electron will absorb the energy in the form of quanta. Either it should go to this energy level or the next energy level. When the electron absorbs energy and goes to the next energy level, it should absorb the energy and go to the next energy level. Now its energy is more. If you have 1 crore loan, and if I give you 50 lakhs rupees, then minus 1 crore plus 50 lakhs, your loan should be minus 50 lakh. Minus 50 lakh is more than minus 1 crore, right? Minus 1 crore is much worst condition. Minus 50 lakhs is better condition. That means as n increases, that is what I want to say, As n increases, what happens to the energy? It is not decreasing, it is increasing. See, as n increases, energy value goes on increasing because energy values are negative. The ground state energy is minus 13.6, correct? This is in the first orbit by 1 square here. What about the next energy state? By 2 square, minus 3.4. Minus 3.4 is greater than minus 13.6. Do you agree? This is more, minus 3.4 is more. And minus 1.51, next energy state, is greater than both. That means as the electron goes to the outer and outer energy levels, n goes on decreasing, but it is inversely proportional to n square, but still the negative values, their magnitude is decreasing. That means answer is increasing, right? Minus 13, minus 10, minus 5, we are increasing, right? Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 like this. So energy is inversely proportional to n square. That means as the quantum number increases, as the electron goes to the outer orbit, the energy value magnitude decreases, but actual energy value increases. Since it is negative, it is becoming lesser and lesser bound to the nucleus. It is becoming more and more free. So with this I will stop this derivation. Tomorrow in the next class we will meet with one more derivation, that is wave number, and till that study this properly. This is very, very important derivation. Hope you do that and don't waste time again the same sentence getting repeated. Utilize the time as much as possible, and I am doing some entrance exam classes also based on this, which will help you a lot, so that you will be ahead by other students by so many steps, right? So thanks for watching my class. Subscribe my channel and you will get all the information then. So keep on working well, keep your health well, take care of your health. Thank you.